Hello. In addition to explaining how it works, this short video definitively documents the fundamental operating principles of HSP's Holographic Passive Tracking Technology, or HPTT for short. While this revolutionary technology can be applied to a wide variety of applications, this passive tracking technology becomes a game changer in the practical application of underwater optical communications. It is well known that electromagnetic radiation in the blue-green spectrum is the only means for transferring information at operationally significant data rates to operationally significant ranges through seawater. However, optical pointing and tracking is still one of the most significant technology challenges affecting the performance, cost, and complexity of these optical communication systems. Subsea optical communication systems must use narrow optical beams to maximize signal strength at receiver terminals to optimize both communication range and data rate performance. But this requires high reciprocal pointing and tracking of these narrow optical beams over the entire field of regard. The hardware required to point and track these narrow beams not only impacts the fundamental phenomenology of underwater optical propagation, but also dramatically complicates the architecture of these underwater communication systems, in many cases rendering them both impractical and unaffordable. Until now, a solution has been problematic. However, HSP has developed a truly revolutionary holographic passive tracking technology that has the ability to accomplish high-rate, precision pointing and tracking without using moving parts. This capability allows for a variety of innovative size, weight, and power-saving architectures that support critical undersea applications with high performance at dramatically reduced costs. This technology is demonstrated here as we show how one of our wide-angle HPTT receivers passively tracks an incoming light signal throughout its entire field of regard without any gaps in connectivity. At the top, a laser pointer simulates an incoming optical communication signal, and it's directed towards our HPTT hologram, which is designed and fabricated to enable tracking over a nominal 40 degrees field of regard, or plus or minus 20 degrees. The HPTT hologram then diffracts the incoming signal light through a focusing lens and onto a calibrated target, simulating a high-speed optical communications detector. It is critical to note that unlike any other system currently available, the diffracted signal light from our holograms on the simulated detector is not only very small, but more importantly, the spot of light does not move its position on the simulated detector, even when the incoming signal is arriving anywhere over the full 40-degree field of regard. This means that the HPTT receiver is automatically and passively tracking the signal without requiring any portion of the system to move. Also, since the spot on the detector is very small at less than 1 millimeter, this enables very high-speed detectors, thus providing the transfer of subsea data at much higher rates. Thank you for your time, and please feel free to contact me, Dr. Chris Lobus, at 619-865-2328, or my business partner, Dr. Gore Sarkeesian, at 310-977-3334.